Dear students, welcome to the session on problems on non-zero initial velocity in one-dimensional wave equation. Those who don't watch the procedure for non-zero initial velocity problem, you can go to the playlist and watch the video and come back here. Because here I am going to use FFS, fast forward mode, because we are going to solve two problems which consist of like almost 80% of the content as common with the procedure. If you learn the procedure, only few steps we have to do extra to complete the problem. So watch that video and come back here. A tightly stretched string with fixed endpoints x equal to 0 to L, that means my length is L, initially at rest. Don't get confused that initially at rest means zero initial velocity problem. A tightly stretched string with fixed points x equal to 0 to L is initially at rest in its equilibrium position. If you see the word equilibrium position, when you see the word equilibrium, it is 100% non-zero initial velocity problem. Now, problem over. Read the question further. If it is set vibrating by giving each point a velocity, that means its initial velocity is given as kx L minus x. So we confirmed in 2 points. One is equilibrium position, and then it is openly said that initial velocity is kx into L minus x. So it is 100% non-zero initial velocity problem. As usual, we start with our steps. So we draw the diagram. There is initial velocity. So the governing equation is y of x comma t. One point x equal to 0, other point x equal to L. And very important, students, suppose in your problem, if they say x equal to 0 to 3, now you say let 3 equal to L, that is 3 centimeter, whatever it is, L. Solve the problem for L completely, and at the end of the problem, put L equal to 3. This is the better way. Don't solve for numbers because we do lot of error in number. Just go for the specific value L, solve the problem and get the score. Now the length is L, so the boundary conditions are y of 0 comma t equal to 0, y of L comma t equal to 0. Next, as usual, remaining steps. The 1D wave equation is y double t is equal to a square y double x, where a square is equal to t by m. Then the third step is the most suitable solution. Take it as equation 1 and we are going to find the constant a, b, c, d and lambda. We have to write the non-zero initial velocity conditions. The first two conditions are boundary conditions, so we don't want to worry, we can copy from the diagram. Y of 0 comma t equal to 0. Second one is y of L comma t equal to 0 for all t greater than 0. The third condition and fourth condition, we should be careful. Here they say non-zero initial velocity. Always the fourth condition should be non-zero condition. I'll take it as f of x. Non-zero initial velocity is f of x. That means if velocity is non-zero, here the displacement is 0. For all 0 less than x less than L. You can see the typed version. And here, next as usual steps, guys. Take the equation 1. Apply 1 in 1, you'll be getting a equal to 0. Substitute a equal to 0 in 1, we'll be getting the new equation 2. Then apply 2 in 2, we will be getting lambda equal to n pi by L. Substitute lambda equal to n pi by L in 2, we'll be getting the new equation. Take it as equation 3. Now my third condition is y of x comma 0 equal to 0. In the initial velocity problem, it would be derivative. Here it is simply y of x comma 0 equal to 0. So apply 3 in 3, we'll be getting c equal to 0. Substituting c equal to 0 in 3, we'll be getting the constants b into d. Since it is a non-zero initial velocity problem, I will take this bd as capital Bn. For zero velocity problem, you will be getting bc, that we take it as bn. Now the most general solution is this. Take it as equation 4. Now to apply the condition 4, it is yt of x comma 0 equal to f of x. I want to differentiate 4 partially with respect to t on both sides. Now take it as 4t star. Apply 4 in 4t star. My yt of x comma 0 is my function f of x and cos 0 will become 1. We'll be getting this equation. Now considering this capital Bn into n pi a by L as small bn. Now we can easily find the bn by L by n pi a bn, where small bn is nothing but my half range Fourier sine series. Now let us find Bn and then we can find capital Bn easily. Therefore, small bn is represented as follows. But I need capital Bn. Substitute here. We'll be getting capital Bn directly. We know that our f of x is kx L minus x. It is tough for integration. So I'm taking it as k into Lx minus x square. Capital Bn is equal to L by n pi a into 2L integral 0 to L k into Lx minus x square sine n pi x by L dx. Now I am taking this k also outside. LL get cancelled. Therefore, capital Bn is equal to 2k divided by n pi a integral 0 to L Lx minus x square sine n pi x by L dx. Now using Bernoulli's formula, we are going to find the solution. Since the function has highest power 2, the Bernoulli's formula is u dv is equal to uv minus u dash v1 plus u double dash v2 etc. Since the highest power of the function f of x is 2, we see three terms exist. U is equal to Lx minus x square. U is equal to Lx minus x square. U dash is equal to L minus 2x. U double dash is equal to minus 2. Triple dash is equal to 0. Similarly, we have to find v, v1, v2. Sin n pi x by L dx. V is going to be minus cos n pi x by L divided by n pi by L. B1 is minus sin n pi x by L divided by n pi by L whole square. V2 is minus into minus plus, integration of sin is minus cos. So cos n pi x by L divided by n pi by L whole cube. Now mapping uv, u dash v1, u double dash v2 and substituting, we'll be getting the answer. Capital Bn is equal to 2k divided by n pi a and we have to put the big bracket to tally this. And my limit is 0 to L. Lx minus x square minus cos n pi x by L divided by n pi by L minus L minus 2x minus sin n pi x by L divided by n pi by L whole square and plus minus 2 cos n pi x by L divided by n pi by L whole cube. Now immediately I can make the sign as 0 at the limit 0 comma L. And now see the first term. If I apply upper limit, it will become L square minus L square. When I apply 0, it will become 0 minus 0. So both the limits are making the problem 0. So I'll say second one is also 0. Only the third terms play a role. So simplifying this, we get like this. Now taking the constants out, we will be getting minus 4k n pi by a into L cube divided by n cube pi cube. Now applying the upper limit, it will become cos n pi. Apply the lower limit, it will become cos 0. Therefore, capital Bn is equal to minus 4k L cube n power 4 pi power 4 a. Cos n pi is minus 1 whole power n. Cos 0 is 1. So we found our capital Bn. Substitute this in equation 4 to complete the problem. Now multiply this minus inside. We'll be getting capital Bn is equal to 4k L cube n power 4 pi power 4 a 1 minus of minus 1 whole power n. Substituting the capital Bn in 4, we'll be getting this final answer. The next problem is almost same like the previous one. Equilibrium position. Then immediately I will say it as non-zero initial velocity problem. And also they say if it is set to a vibrate, giving each point a velocity, therefore initial velocity is non-zero. So as usual, we do step 1. The 1D wave equation is y double t is equal to a square y double x, where a square is equal to t by m. Then the third step is the most suitable solution. Take it as equation 1 and we are going to find the constant a, b, c, d and lambda. My f of x is given as v0 sine cube pi x by L. And I said the another clue in the last video. If you see a trigonometric problem, never miss it because we are not going to do integration. We just going to do comparison and complete the problem up to the step f of x is you can see the previous problem. Now my f of x is going to be v naught sine cube pi x by L. So we use the formula for sine cube theta. Sine cube theta is equal to 1 by 4 3 sine theta minus sine 3 theta. Applying this in the LHS will be getting like this. Now simplifying the RHS, substituting the value 1 by 1 n equal to 1, 2, 3, 4 etc. will be getting like this. I'm going to compare the coefficients both sides. Sin pi x by L, sin pi x by L. Sin 3 pi x by L, sin 3 pi x by L. Therefore, my 3v naught is going to be my b1 pi a by L. B2 I don't have anything, it is 0. B3 3 pi a by L is minus V naught by 4 and all the remaining terms are 0. Therefore B1 is equal to 3 V naught L by 4 pi a. B3 is equal to minus V naught L divided by 4 into 3 pi a. So finally we can write the values of capital B1, B3. All the remaining elements are 0. So now when I go for my most general solution y of x comma t, only B1, B3 exist. So I will write this as capital B1 sin pi x by L into sin pi at by L plus B3 is sin 3 pi x by L into sin 3 pi at by L. Now substitute the B1, B3 values to get my final answer. That's it, students. Hope you understand. Now you'll be very confident with wave equations. It is very easy if you follow the procedure. 80% of the problem over. Only we have to work for the 20%. Thanks for watching. Subscribe our channel, share to your friends, click like. It's our channel. Whatever you have a doubt, you post in the comment box. We are here to help you. See you in the next video. Thank you.